So, here two sets are given. This is basic on the basic idea of Cartesian product, the question is framed. So, there is one set A, there is one set B, and here there is one set which is A cross B and there is one set which is B cross A. We have to find the common elements of A cross B and B cross A, and then we have to count them to find the total number of common elements. Okay. So, when we take A cross B, we always get ordered pairs like this. So, A cross B set contains all ordered pairs. Ordered pair means pair written in an order. That means if I change the order, then meaning changes, the interpretation changes. Okay. So, x comma y and y comma x are treated as two different ordered pairs. Now, it contains all ordered pairs x comma y such that x is belonging to A and y is belonging to B. So, this is the definition of A cross B. We also call this as set builder form. Okay. Now, x must belong to A and y must belong to B. So, A cross B is such that this rule is satisfied. Now, what about B cross A? In B cross A, again we will contain this set will contain all ordered pairs x comma y such that x belongs to B and y belongs to A. Okay. Now, here if you observe, how many elements are there in set A? There are 5 elements. How many elements are there in set B? There are 4 elements. So, to select first element x, we have how many options? 5 options. Now, to select second element y, how many options do we have? We have 4 options. So, we can straight away say that n of A cross B, that means total number of elements in A cross B will be 5 into 4. Okay. Now, similarly, we can also get n of B cross A. Okay. So, here for selection of x, x has to come from B, we have 4 options. For selection of B, we have 5 options. So, this will be 4 into 5. So, I hope you understood the logic here. But if we want to take the intersection of these two, then first element must belong to A and also it must belong to B. Okay. So, first element x must belong to A according to this set builder form, and according to this set builder form, first element also must belong to B. So, just check how many elements are common. Okay. So, here if I observe how many elements are common, 2, 3, these two are common. Okay. So, there are 2 possibilities for selection of the first element. Now, what about y? So, y also must belong to both sets. So, for selection of y also, how many options are there? 2 options are there. So, total number of elements in this set, which is intersection of A cross B and B cross A, will be 2 into 2, which is 4. Okay. I hope you have understood this logic. Here we do not have to form sets, we can always understand it by the definition and we can use our counting principles to get the answer. Okay. So, here one idea of doing this is we can form the A cross B set, we can form B cross A set in roster form. We write all of them and count how many are common, that is one way. The other way is you can smartly go by definition and do the counting by counting principles. Okay. So, here the answer to this question is 4. Okay. So, I hope the logic is clear. Okay. Next, if you want to make a note, please make a note. Okay. So, now can we move on to the next question? Okay. So, here before I go to the next question, let me explain you the relations first. Okay. Because most of the questions that come from sets and relations chapter are of 2 types. One type is questions are based on the set theory, Venn diagram, A cross B. So, out of them we solved already one question. Okay. So, otherwise if you get any questions like in a classroom some students passed in mathematics, some students passed in physics, some students passed in chemistry, how many students passed as common in all of them, that kind of questions can be solved using Venn diagram. Okay. So that anyway students are good at, so I have not touched that idea. The other type of questions come from the types of relations. Okay. So it is necessary that we understand what are these types. So let us take a set and try to understand this. Suppose let us say I take a set A as 1, 2, 3, 4. Let us say this is my set. And let us say I take an example of a relation R1. Okay. So I will just take this onto the next page. Okay. So let me take a set here 1, 2, 3, 4 and let me take one relation R1. Okay. This contains, in fact here if I take A cross A, this will have how many elements? It will have total 4 into 4, 16 elements. Okay. Now for a simple simplicity, I will take only 3 elements here. So A cross A will contain 9 elements. Now let me list down all 9 elements. Okay. See, I am taking little slow approach here because it is important that you understand how we get these relations and how to interpret them. Okay. So learning blindly is not going to help us. So let me just take you from basics. Okay. So now starting with 3, 3 comma 1, 3 comma 2, 3 comma 3. Okay. So this is my A cross A. So let us say I take one relation R1 here which contains elements like this. Okay. Now let me take another relation R2 which contains 1 comma 1, 2 comma 2, 2 comma 3, 3 comma 3. Now let me take one more. Okay. So another. So let us say I have taken 4 relations here. Okay. So now imagine that I am trying to compare all of them. Okay. So these are 4 relations. Now let us go back and look at the definitions. Okay. So our workshop is ready. This is our workshop and here we learn concepts. We apply these concepts on this workshop. Okay. So let us look at this. Identity relation. Okay. So what is identity relation? Identity relation has elements like x comma x for all x belonging to A. Okay. So here we have not taken 4. Okay. So now check here. Okay. So how many relations out of these are identity relations? Okay. Only the first one is identity relation because for this set 1 comma 1, 2 comma 2, 3 comma 3 are already present in that. Okay. Can we call the others as identity relations? For example, in R2, 2 comma 3 element is not falling under the definition of x comma x. So this is not identity relation. Similarly, others are not identity relation. So only the first one is identity relation. In identity relation, remember that we will get a definition like y equal to x. Okay. So for all elements in that set, x and y must be always equal. That means image and pre-image must be always equal. Okay. Now what is reflexive relation? So, reflexive relation goes like this. If all elements of the form x comma x, if all elements of the form x comma x are belonging to R, okay, where x is belonging to set A, where x is belonging to set A, then R is reflexive. Okay. So, that means here if we observe, out of all these relations, how many are reflexive relations? This first one is definitely reflexive relation because it contains all possible ordered pairs of the type x comma x. Now, similarly, if I check the second, 1 comma 1 is present, 2 comma 2 is present, 3 comma 3 also present. Now, irrespective of whether there are other elements or not, if these three are present, then it is reflexive relation. Okay. And similarly, the next one, see if 1 comma 1, 2 comma 2, 3 comma 3, if all possible y equal to x type of ordered pairs are present or not. So, 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there. So, this is also a reflexive relation. Okay. Now, similarly, for R4, so here 1 comma 1 is present, 2 comma 2 is present, but 3 comma 3 is not present. So, this is definitely not reflexive relation. Okay. So, I hope you have understood the idea here. So, in a way we can say that all reflexive relations are not identity relations, but all identity relations are reflexive relations. Okay. So, reflexive relations are superset, identity relations are subset of that set. Okay. Now, next, what is symmetric? Symmetric is easy. Most of the confusing relations are these two, identity and reflexive. Okay. Now, symmetric goes like this. If A comma B and B comma A, if both of these are present in that relation R, then it is symmetric. Then R is symmetric. Okay. So, now let us look at this. We are looking for A comma B and also B comma A. Okay. So, now look at this. If we have 1 comma 1 and even if we flip these input and output, we will get the same ordered pair. So, is identity relation or symmetric relation? Yes, it is. Okay. So, this is definitely a symmetric relation. Now, similarly, R2 if you check. Okay. 1 comma 1 makes it symmetric, 2 comma 2 makes it symmetric, 2 comma 3 if here input and output are different. So, for this relation to be symmetric, 3 comma 2 also must be present. Okay. So, is 3 comma 2 present here? No. So, this is not symmetric relation. Okay. Similarly, check here, 1 comma 1 is there, 2 comma 3 is there. So, 3 comma 2 must be there, it is already there, 2 comma 2, 3 comma 3. So, this is symmetric relation. Okay. So, even if we have one element whose reflection is not in the set, reflection means swapping of x and y. Okay. So, even if we have one element whose reflection is not in the set, then it means it is not symmetric. Okay. Okay. So, similarly, the last one if we check, this is also not symmetric. Okay. Now, let us look at the next case, transitive relation. You know this relation. Okay. So, if A comma B belongs to R and B comma C and B comma C belongs to R, then A comma C must belong to R. This is the rule, must belong. Okay. This is the condition for the fourth, which is the transitive. So, here logically think about this. If these two are present, only then we should look for A comma C. If these two are not present, then there is no need of checking A comma C. Okay. So, that means out of these two, if only one is present, then we do not have to check for transitive. Okay. So, let us look at the examples and see. So, rule is if both these are present, then A comma C must be checked. Okay. So, let us look at this. So, here A comma B 1 comma 1, there is no other element starting with 1. Okay. So, similarly 2 comma 2, there is no other element starting with 2. 3 comma 3, there is no other element starting with 3. Now check, now tell me, is it transitive or not? Of course it is. Okay. This is transitive. Okay. Because if I have, look at this, if I have A comma B and B comma C, only then I will check for A comma C. Okay. So, if I have only A comma B and I do not have B comma C, then I do not have to check A comma C. Okay. So, now let us look at the others. 1 comma 1 does not have any issue, okay, because this is symmetric. So, 2 comma 2 is there. Now, 2 comma 3 is there. So, A comma B, B comma C is there. So, A comma C is must. So, 2 comma 3 is already present. So, these two are satisfying. Okay. Now, the other way, 2 comma 3 is present, 3 comma 3 is present. So, now if I go for A comma C, which is again 2 comma 3, which comes back to the same thing. Okay. So, that means we got the result. Okay. So, these 3 elements do not have any issue. Let us go for the third element. 3 comma 3 is present. Now, element starting with 3 is not present here. So, this last element also does not have an issue. Okay. So, when it comes to this definition, first 3 elements have satisfied the definition completely, but last element also satisfies, because here the second element is not there, only first is there. So, it is not an issue. So, this also is transitive. Okay. Now, let us come to this. So, here if I check 1 comma 1, it is already satisfying, 2 comma 3, 3 comma 2, so 2 comma 2 must be present. So, this is also satisfying. 3 comma 2, 2 comma 2, so 3 comma 2 must be present, it is also satisfying, and 3 comma 2 and here 2 comma 3, so 3 comma 3 must be present, so this is satisfying. Similarly, 2 comma 2 is also satisfying, 2 comma 2, 2 comma 3, so 2 comma 3 must be present, so this is also fine, and 3 comma 3 is one element. Now, starting with second 3, we have 3 comma 2. So, AC will be 3 comma 2. So, this is also satisfying. So, luckily this is also transitive. Okay. Now, let us look at the last one. 1 comma 1 is there. So, this does not have an issue. 2 comma 2 does not have an issue. Now, 3 comma 1, 1 comma 1. So, 3 comma 1 must be present. Okay. So, luckily all of them turned out to be transitive here. Okay. I have randomly created these relations just now, and accidentally all of them came out to be transitive. Okay. So, it is just a sweet accident. So, there could be relations where they are not satisfying transitive. Okay. Suppose let us say I have another, let us say I am taking 1 comma 3. Okay. Now, look at this, 1 comma 1 is present, 1 comma 3 is present. So, 1 comma 3 must be present. Okay. So, that does not have an issue, and here 3 comma 1 is present, 3 comma 1 is present, 1 comma 3 is present. So, 3 comma 3 must be present, but that is not satisfying. So, after adding this element, this is not transitive. Okay. So, I hope this is clear with you. Okay. But the moment I added one extra element, these two also needs to be rechecked, because we checked these two according to the earlier setup, but now the setup is changed. Okay. So, I have just modified it to make sure that at least one relation is not transitive. Okay. So, this way we can verify if a relation is identity or reflexive or symmetric or transitive. Okay. So, identity is generally fixed for a set. Okay. So, if I take this set with 3 elements, so identity relation is fixed for that. Okay. So, generally our checking goes only for these RST. Okay. Now, coming to the next last one, which is the equivalence relation. So, if a relation is these 3, that means reflexive, symmetric and transitive, then it becomes the equivalence relation. So, here if you check in which relation all three are present. Okay. So, this R3 is the relation in which all three are present, which are reflexive, symmetric and also transitive. So, this becomes equivalence relation. Okay. So, this is a basic example of how to proceed with the problems in the exam. Okay. So, let us look at one problem here. So, there is a set given here A, and based on this set, so there is a relation R which is going from A to A is given. Also, all these relations, reflexive, identity, transitive, symmetric, all are defined from A to A only. Okay. So, now the question is asked whether this relation is reflexive or symmetric or transitive. So, that is represented using this representation. R stands for reflexive, S for symmetric, T for transitive. If we put bar, then it means it is not transitive. Okay. So, how do we check? Follow the same pattern and check. Okay. So, I have explained the method completely here. So, just follow that method and solve this question. Okay.